This is section what, 4-5, and we're just going to go over the homework, a couple problems, a couple proofs, and we're going to start with number 10. So let's do that. So we've got that's equal to this. So I copy and paste and go down here like that, and then you've got a line goes like this, and then like this. Again, I'm just going to run through like the sketch of it, not, you know, write down every little thing. So I won't even write down the given, but I will put the letters on here though, and then mark the picture, and we'll just talk through it. M, S, and P, Q, and R. All right, and let's see what we have. It says, let's see some different color. It says MS equals RQ, line segment MS. So this one equals this one. And it says MS is also parallel to it. They even mark this in the book for you, don't they? All right. But they didn't have to. And you need to prove that the two triangles are congruent. That's all the information they'll give you. Well, at least you know a side, don't you? So I'll put side right here. So let's see. What else do you think you can figure out from these two triangles that they don't tell you? Kevin? PQR and MSP, is that what you said? S? Yeah, so angle S and Q? Yeah, they are equal to each other. Why are they equal to each other? Good, they're alternate interior angles. But what do you have to say first, though? You have to say the lines are parallel first, okay? And that's given. Then you would say alternate interior angles. So we've got a side. I'll just put a little A in here. Is that all right for angle? Make sense? It's not like an angle A. I just put, you know, that so I know it. So I know a side. I know an angle. Is there anything else I can find? Katie, what else? M and R. Good. Okay, so M and R are equal to each other. And what's the reason for that? Yeah, same exact reason as the other one. They're also alternate interior angles, aren't they? Cut by transversal. So that's another angle. So I got another angle right here and right here. Now, why are the triangles? Is that enough information to prove the triangles are congruent? Yeah, it is. What is it? Angle, side, angle. Because what's true about the side? It's in between the two angles. It's the included side. Okay, so I would say angle, side, angle. Make sense? All right. Good. And you said also which one? 12? Is that what you said? Well, look where well, it depends on what you marked. If you mark this angle and this angle and this side, it's angle, side, angle. Why?
Because the side is the...
That's right, because the side is the included side. It's in between the two angles. Okay. You can do that. You can do that as well. Watch. You could have said this and this are equal to each other, right? And then not one of these. So you could have like left this one out right here. Yeah. Yeah. There's a lot of times. A lot of times there's. Yeah, we've mentioned that before. That there's not always just one way to do these. I think sometimes there is only one way, but then other times there are a couple different ways. You could have done this as well. You could have said, but I was just going by the stuff that you were giving me, right? And by the information that I gave you, it would have been angle, side, angle. On this one, it's angle, angle, side. Okay? So, yeah, you could go either way. But you must use the reason that you use these statements for, okay? So if I had an angle and a side in between the two angles, you would use angle, side, angle. If I have two angles and a non-included side, then you would use angle, angle, side. You good? All right. Which one are we doing? 12. All right. Let's draw that thing out. Looks like that, and that, and this. All right. And you got this thing right here going to there. All right. And let's put the letters in here. That's M, J, K, L down the bottom. All right. And what do they tell you? It says line segment KM bisects angle JML. So KM, this thing right here, it bisects angle JML. That's this top big angle up here. So let's, so we're bisecting that whole angle. What does that mean then if this MK or KM bisects that whole big angle? What does that tell you? It means these two angles are equal to each other. So I could mark this equal to this. But you have to say that it's given that it bisects the angle first, right? So you make sure you say that. And so I've got an angle equal to another angle. What's the reason? If KM bisects this, it splits it into two equal angles. Exactly, okay, the definition of angle bisector, okay? All right, so you've got an angle. Do they tell you anything else? Yes, they do. They say angle J equals angle L, so we can mark that as well, can't we? Everybody with me on that? Mm-hmm. All right, so angle J equals angle L, and what's the reason for that? It's given. Right, not all at once now. Okay, so angle, you got two angles. So I've got an angle here, an angle here. All right, so two angles equal two angles. Do they give you anything else? Nope. And they want you to prove, I'm going to do this in a different color, okay? They want you to prove that JM is equal or congruent to LM. All right? I don't know that. That's why I put it in a different color, okay? I don't know it, but that's what I'm trying to prove. So what's the good way to prove that segments are congruent to each other, Katie? Good. You got it. Make sure the triangles are congruent, okay? Let's prove the triangle's congruent first. Then once we prove the triangle's congruent, then what can we say about the two blue sides? They would be equal because of... Come on. We use this. What is it? Yeah, CP... Yeah, CPC, TC. You need to understand what that means. What does it mean? Corresponding, not congruent, corresponding parts of congruent triangles are congruent. That means if I can prove that this triangle is congruent to this one, then the parts that are corresponding, which MJ and ML are corresponding, aren't they? When they match up, if I folded that on top of each other, you see that?
Yeah.
Okay, then they would be equal to each other. So that would be my last step right there. So I'm trying to prove that this triangle is congruent to this triangle. How in the world can I do that?
Oh, I know.
Tell me. Now remember, I'm going to erase these because we don't know this is true.
You said that MK equals MK.
That's very true, so we can mark that. All right. Is that enough right there? Is it angle, side, angle? Come on, think about it. We just went over it. It's angle. Is the side in between the two angles that we've marked equal? No, it's not. It's angle, what? Side. Do we have an angle, side? Absolutely. Okay, we do have two angles and a non-included side. And that's basically all there is to it. Why, by the way, why is MK equal to MK?
Because of the
Reflexive property, that's right. Okay, anytime something's equal to itself, it's a reflexive property. This is one that shows up a lot. You need to see it right away. Like that other one. Did you see vertical angles right away as soon as you looked at this? I saw that. That just jumped out at me. Okay, there are certain things that just jump out at you. Vertical angles is one of them, and reflexive property is one of the ones that just kind of jump out. As soon as I look at it, I'm like, oh, that side is shared by both of those triangles. That's reflexive property. Okay. Question.
So let's say the including angle, there was an including angle.
Like this one right here, or what do you mean
I'm sorry,
included?
let's say there was an including side.
Like
to make it
like this one.
Angle
But see, this is what we're trying to prove. We're trying to, but there's.
Yeah. So right. So my question is like, when you're trying to figure out if it's angle side angle or angle side.
Yeah.
Can you just read it off the way you see it, or do you have to?
Yeah. It's. I don't know why there's so much difficulty on this. It's just it's the side between the two angles. Look,
right.
Here's an angle. Here's a side. Do I know this angle here? No. I don't know that this one's equal to this one yet, do I? Okay, so I can't use angle, side, angle. Look, angle. Do I know this side? No. So if I knew this side, I could go angle, side, angle. All right? Look at my two angles. I've got an angle and an angle. Look at this side right here. Is it in between the two angles? No, it's not. If it's in between the two angles, it would be angle, side, angle. And it makes sense because, look, that side is in between the two angles. But it's not this, is it? Because look what I have. I've got an angle down here. I've got an angle up here. I don't know the side in between, do I? So I can't put the side in between. And I know this one side. and it's not in between. See that? So it has to be angle, angle, side. Now, you could have done this. This would be a little bit of a waste of the time, but watch this. Everybody watching? You could have said this. If I know two angles of one triangle equal two angles of another triangle, what must be true about the third angle? That must be equal as well, right? So, well, not necessarily. Well, if they're equal to each other, they would be. Yeah, if they were equal to each other, absolutely they would be, right? Because if they're exactly the same and they form 180 degrees, they both have to be 90 degrees, wouldn't they? All right. But what I'm saying is this: if you really, really wanted to go angle, side, angle, you could, but then you'd have to put in another step, an extra step. Does that make sense? You would have had to say, well, actually, one extra step. You would have had to say that this angle is equal to this angle because of the third angle theorem, and then you could go angle, side, this angle right here. But why bother putting in that extra step? Wouldn't you agree? Okay, I don't think it's necessary to do that. That's why angle, angle, side is nice, because we don't have to do that extra step. We talked about that a little bit yesterday in class. All right, does that clear things up a little bit? All right. Now the triangles are congruent. If the triangles are congruent, then MJ equals ML because of what? Right, corresponding part, CPCTC. We good?
Yeah.
All right. See, I told you, the more you do this, the better you get at it, right?
Yeah.
This is not one of those things where I teach you one day and you're able to get it that night and be fine with it, okay? And I told you that from the beginning too, didn't I? I said that from the beginning, that this is a process. This is not something you just teach in one day and then you got it. It takes some time, and I've been taking my time with you. I even give you a little worksheet today to kind of let it sink in a little bit more. You know what I mean?
I feel like, you know how you taught us to write when we're doing our two contours to write on the side, like side, when we find a side and an angle?
Yeah.
I feel like I mess up sometimes because I read it the way I write it, so I'm like, okay, that's angle, angle, side. But then I realize, no, it isn't included side.
Right. I understand that. But the way to combat that is to do the proof in your head first, okay?
Right.
Do it first, and like, we weren't going to use these things right here, were we? Originally, okay. So when I do it, and I write it, I do this all right here, and I'm like, okay, I'm going to go this angle first, then this angle, then this side. Okay. Then do that in your proof. When you do your two columns, say that J equals L first, and then figure out that this angle is equal to this angle, and it's given that it bisects, and then you say they're equal to the definition of bisector, so you do that angle second, right? So you do that angle first, that angle second, and then you could go MK equals MK, and that's your side. Then you have an angle, angle, side. So what you have to do is you have to, prepare. You got to be...
Yeah, you have to think about it.
You have to think about it ahead of time, right?
Yeah.
And prepare your two columns so that it does go in the order that you want to say that they're congruent. Make sense?
Yeah.
All right, very good.